Xin chào, hello everyone. Thank you for joining my sessions. My name is Talia. I'm from Vietnam and currently located in Sydney, Australia. My Vietnamese name is Kang Ngọc Dạ Thảo. I'm a manager of some product, the organizer of this event. I'm also a CPA Australia, a finance and business intelligence consultant. I work on a variety of projects, primarily as a project manager and lead modeler, helping businesses with financial modeling, reporting, visualization reports, and automation. In addition to consulting, I'm in charge of an Excel challenge blog series on someproduct.com called Final Friday Fix and Monday Morning Mailing. My tool sets include Excel, Power BI, Power Automate, Power Apps, and SQL. This year is my fifth year participating in Excel Virtually Global as a coordinator and presenter. In my previous years, I have covered various topics from Excel, ChatGPT to Power Platform. So if you are interested, you may find the recording links on my LinkedIn profile or some product YouTube channel. This year, I will present a topic that includes a combination of Excel and Power BI. As you can see from the title, today I will walk you through how recursion is handled by Excel and Power BI, including Power Query and DAX. I assume that you have known a little bit of M-code and DAX. If you don't, that's alright. It's still useful to follow my demos so you can apply it to your own problem. Let's get started. Firstly, what is recursion? It basically means what happened next depends on what happened before. It has two properties, one or more base cases and recursive step. Base case is a null value that doesn't need recursion. It is usually a starting value. Recursive step is a formula that produces the next recursion result. An example here is factorial. The base case is 0 factorial equals 1. For all positive integers, n factorial equals n times n minus 1 factorial. Then why does it matter? In real life, recursions show up everywhere, like balances on balance sheets that the prior period is carried forward and adds movements to get the current. It is used to calculate compound interest, cumulative growth rates, time series smoothing techniques such as simple and exponential moving averages. In math, it appears in Fibonacci and recurrence relation. It is also used in forecasts based on historical data. I'm going to show you how to deal with recursion problems in Excel and Power BI via some demos from basic to advanced. In each demo, I will use and compare different tools. In Excel, you can use normal grid formula or split arrays. On cell-by-cell basis, you can simply refer to a previous cell in the formula and copy it to the right or down. As for dynamic array, we have scan, reduce, and recursive lambda functions that allow iterations and accumulation of values. In Power Query, there are some built-in functions that can handle recursions, such as list first n, list accumulate, and list generate. I covered recursive lambda and the add symbol in my EVG sessions 2 years ago, so I won't talk about them in details today. Unlike dynamic arrays and Power Query, DAX has no native recursive functions. There are some creative workarounds that we can utilize, such as accumulations and close form formula. Although it's a bit harder than the other tools, I will walk you through some of the techniques I often use. Okay, now let's start with the first demo that is simple yet commonly used, running total. In reality, we usually calculate running total for balances such as cash, loan, inventory, accumulated depreciations, or any month-to-date, year-to-date metrics. Let's use Excel to do the calculations. This is an Excel starter file that I have prepared for you. Let's come to the first demo tab. This is the table that contains some random number that I will use to demonstrate this example. Before we start, I will explain some of the cell style that I use in this file. Yellows mean these are input cells. Blue means these are the places where I will enter the formulas. And I have another cell style that is gray. That means it is internal reference to another cell. Okay, now let's write the first formula. So the running total is just simply taking the current value plus the previous accumulated number. So for the first cell, it will be equal to this number. The second one will be this value plus the cell above. And then I would just drag the formula down. This is correct, but in financial modeling, usually we want to have one consistent formula across the whole block of calculations. So the tip here, the previous cell of this cell is a text. So if you use plus this cells, it will return an error. So what I do is I grab it inside the end function. End function will convert text into 0 and keep the number as it is. And then I just simply copy down the formula. Before talking about dynamic arrays and power query solutions, let's discuss some similarities between scan in dynamic arrays and list.accumulate in power query. The first thing is their syntax. They both have three main arguments: initial value, a list of values, and a custom function. Their orders are a little bit different as you can see. Regarding the final custom function arguments, they both require two variables. A stands for accumulator and V is the current value. In scan, we use lambda or eta lambda, while in list accumulate, we use the syntax that is A, V between the brackets, equal and higher than symbols. Another difference between these functions is the accumulator A. In scan, A can only store one value for the previous result and return all results in a split array, while list.accumulate can store a list of prior values and return the final A only. If you want to replicate the behavior of list accumulate in Excel grid, you can use the combination of reduce and V or H stack functions. To calculate the running total, here's are the formulas. They are pretty similar. I will show you how they work in Excel. For the dynamic arrays, I will use scan function. Initial value will be 0 because I want the sum to start at 0. The array will be this column. For the function, you can use an eta function. In this case, it will be sum, like this. Or you can use a lambda function, that is like this. They will both return the same result. Okay, now I will show you how to use power query to calculate the running total. First, I select any cell in this table. Go to Data tab from Table Orange. The first method is to use list first and function. I will need to create an index column, but before I do that, I will rename this step. I will call it base. Next, I go to Add Column Index drop-down from 1. Under the same Add Columns, I click Custom Column to create a new column. I name this column as RT for running total. I will use list first and function to get the top end value of the values column here from the previous step base, and then open bracket value, that is the name of the column value. Then number of value I want to get is the value of these columns. So I just need to double click at index and then I close the bracket. Okay, so it will generate the list of top end item. You can see here. I will then sum these numbers together. So I will click at the wheel here and type list.sum outside of the list at first end and then close bracket at the end. So this is the result I need. Now I just need to right click at it, remove all the columns, and then go to File, Close and Load to, and then select Table, Existing Worksheet, and I put it here. Okay. So this is the fourth method. It is a slow method because every row it have to recalculate the total of all value from the start up to the current rows. If your data is lag, it will slow down significantly. I will show you another method that is faster using list.accumulate. So again, I select a cell in this table. Go to Data from Table Orange to bring it into Power Query. Currently, this is a table. I want to convert this table into a list. So I right click, drill down. It has become a list. And then I will buffer it into the memory so it will run faster. And then I rename this step as value list. To create a new step, I click at the FX icon here. I write some M code using this accumulate. The starting point is an empty list using this syntax. Accumulators will be a comma v inside the brackets equal and higher than symbols. And then it will be a concatenate with a new list a plus v. And let's see the result. Oops, there's an error. The reason for the error here is because A is a list and we are trying to add a number to that list. So what we need to do is instead of A here, we need to use list.last so we can extract the last value of A. But they all return no. The reason for it is because for the first row, list.last A will return no because it is an empty list. When you use no plus a value, it will return no. So in order to avoid this, I will convert this no into a number. So I just open bracket here, double question mark 0. So this just means that if the value here is no, it will return 0 instead. So this is the result. And then I rename this one to rt underscore fast. Then go to file, close and load to. I will place it here. Another fast method is to use list.generate. Similarly, select a cell in this table. Go to data from table orange. I will rename this one to fast2 and then I will convert this table into a list. Use list.buffer outside and then I add a new step. Now I will use list.generate because this formula is a little bit long, so I will expand the formula bar here and write it into multiple rows. The first argument is the starting value. I will start with this syntax for a function. The starting value includes two variables. The first one is counter equals 0. The second is rt. That is the first value of the value list. So it's just the name of the value list here. And then I want to extract the first value on list. Power query count everything from 0. So I will use 0 inside curly bracket here. And that is for the first argument. The second argument is the condition to go to the next iterations. So here I will have each counter less than the number of value in the value list. The next argument is the rules for the next value. Counter will be equal to counter plus 1. rt equal to the previous rt value plus current value in the value list. So it will be value open curly bracket and the counter value. The last argument of list generate is an optional one. I will specify what field I want to return. So in this case, I only want to return the rt field of this record. So it will be like this. Here I need to remove the close bracket. Okay, so this is the result. Now I just need to go to file, close and load to table existing worksheet and put it here. Okay. So here's add all the result. Now let's find out a solution for DAX. Each value have to be calculated independently, so we cannot refer to the previous value of itself. What you can do is we use the running range inside the sum function. So first I will select a cell here and then I change this to column C. Then I use column C6 again because I want to drag this formula down and I want to encode the first cell. So I put a $sign for the top rows here, enter. And here I just simply drag it down. In DAX, you will use a similar method to this formula. Let's come to Power BI. This is the starter file for Power BI that I have prepared. Here add the measure that I have already created. The first measure is just simply the sum of this column and it's already show the number here. Now I will create a new measure and I call it 1.2 RT foreign total. So first I want to know what is the current month. I will create a variable and call it current month. So it's simply the selected value of start of month. Then I will calculate the values using this measure 1.1 value. The condition here is start of month less than or equal to the current month variable we have created above, comma. Then I clear the filter of the calendar table. And let's see how it works. I just drag it into the visuals. So you see, it also calculate the value for some of the blank months. So I will adjust this formula a little bit. I will add an if condition outside of this formula. If on point on value, that just means if this value is different from 0 or different from blank, it will calculate the running total. Otherwise, it just simply return false or blank. So now it has been removed. I will reformat it to whole number and then comma separator. Looks good. Now I will try to test it with this slicer. However, the running total seems to calculate since the start of all months. It's not calculated since the start of my selected range. So instead of using all here, I will change it to selected. So you see now it's recalculate when I change the range. Okay, the second method is to use a visual calculations, and it is much quicker and easier to write. Just right click at the visual, new visual calculation, running sum. Here you just simply click at the arrow and select the value columns because we want to calculate the running total of the value columns. And here I will rename it to RTVC, stand for visual calculation, and then hit commit. So you see it also return the same result. In order to remove the decimal point of the visual calculation, you can go to the format pane, go to property, data format, select the visual calculation, and select whole number here and turn on the thousand separator. So it will return the same result. After the first simple demo, the second demo is a little bit more complex but still easy to create, that is cumulative percentage. Here I have a table and I want to calculate the cumulative growth rate of these percentages. So what I do here is I will use similar technique we have for the running totals using the AND function and refer to the previous cells, multiply with open bracket 1 plus the current percentage and then minus 1. Then I just simply drag this one down. For the dynamic array, similarly I use scan function. Initial value will simply be 0. The array is this columns. The function here will be lambda a comma v comma 1 plus a times 1 plus v and then minus 1 and then I close the bracket. So it will return the same result as this. For the power query solutions, I will just select a cell in this table, go to data, from table arrange. This time I will only use list accumulate options. So first I right click at it, drill down to extract this column as a list. Then I use list buffer outside. And then I add a new step by clicking at fx and I type list accumulate. The starting value will be an empty list. The function here will be a comma v inside the brackets equal higher than a concatenate with 1 plus list dot last a. In case list dot last a is null, I want to return 0, so I will put it inside the bracket. Use double question mark 0, so it will return 0 instead, and then I multiply this with 1 plus v and minus 1 outside. Okay, so now I go to file, close and load to table, and I place it here. I apply some flatting so it's easier to read. So you see it returns the same result as these two solutions. The last one is the DAX solutions. Before we go into Power BI, similarly, I will demonstrate how we calculate with an Excel formula. Similar to the running total, we can use a running range, but we don't use sum function, we use a product function. And it will be 1 plus, select this, and then I change this to column C. I encode the rows here, and then I minus 1 outside. So you see, this is the formula that we will use in DAX. This is the data that I have prepared for you. Similarly, I have a function here for the escalation rate. Now I create a new measure. 2.2 cumulative percent. Similar to what we have written in running total, maybe I just copy the same and I change a few things so it will be quicker for us. I put 1 as a placeholder for now. I just copy the same measure and paste it here. For this one, I will change it to 2.1. This value will need to become product X of the escalation table. It will be 1 plus 2.1 measures and close the bracket. And then outside of the calculate function, I will minus 1 here. And then I just drag this measure inside. I need to format it as percentage. I will use the same formatting as this one with the bracket for the negative by copying this format. and paste it here. Okay, the next one I'm going to show you how to use visual calculation, which is quite quick to build as well. So right click at the visual, new visual calculations. So this time I will add a custom measure, cumulative percent VC stand for visual calculation product X function. I will use a window function. Window works like the running range we created in Excel, that is anchoring the first row and then select the range up until the current value, that is 0 absolute and 0 relative. And I want to summarize the rows in the table, so I use rows here. I will order this table by start of month columns and it will be ascending order. So this is for the window function. The calculation I will use here is to use 1 plus 2.1 and then I close the bracket for the product X and then minus 1 outside. So this is the result. Just go back and then I go to the format to change the format. Custom, and I use the code that I copied before. So that's for the demo 2. The third demo is commonly used in business and a little bit more advanced than the first 2 demos. It is about a time series smoothing technique called exponential moving average, or EMA. What is EMA? It's a technique to smooth out noises in your data. It applies more weight to the recent value and less weight to the older one. This is the formula for it. In EMA, alpha is the smoothing factor. The smaller alpha is, the smoother but slower the average response. The larger alpha is, the more jumpy and reactive it becomes. Alpha can be any number between 0 and 1. Analysts often want an EMA to behave about the same as end-date SMA, that is, simple moving average. So this formula for alpha is a convention that ties EMA to a SMA length n. So business user can say 7-day EMA and knows it reacts about as quickly as a 7-day SMA. In practice, EMA is often used to analyze time series data such as stock price, sales, website traffic, and allows us to spot trends without being distracted by noise. We will show a business case called sales trend smoothing. A retail company wants to monitor daily sales, but raw numbers are too volatile due to weekends, promotions, or holidays. Instead of an SMA that has equal weights and fixed window, they use EMA so recent sales weigh more heavily while older sales gradually fade. So the data we have includes 2 columns, days and sales. The requirement is to create a 7-day EMA trend line. The outcome is for the stakeholder to see directional trends instead of noisy daily fluctuations. It helps managers make quicker decisions. So if the sales are consistently above the trend, they will need to stock more. If it is below the trend, they need to adjust the promotions. As usual, we will work on Excel first. This is the simple file I have prepared for demo 3. Here we need to calculate the exponential moving average of 7 days. We use this formula to calculate alpha, so it will be equal to divided by open bracket and plus 1 close bracket. EMA0, I will take the first value of all sales, so index this sales column, comma 1. Next, I want to generate a list of T counters. So it will be n of the previous sales plus 1. I just drag it down. For the first solution, I will use this formula equals to alpha multiplied with the current sales plus the open bracket 1 less alpha close bracket multiplied by the previous value. If T equal 1, then use this EMA 0, otherwise use the cells above. Now I just drag the formula down. You see on the right hand side here, I have plotted 3 lines on the charts for sales, exponential moving average, and simple moving average. The raw sales are noisy and volatile, while EMA, the blue one, reacts faster to recent trend weighted to the latest data. And the simple moving average, the green line, seems to smooth evenly across the past 7 days. It has more lags and flat edges. Okay, now let's come to the dynamic arrays solution. So I will use scan function. Initial value will be EMA0. The array will be this column, and the function will be lambda a comma v comma alpha multiply with the current value, that is v, plus open bracket 1 less alpha multiply with the previous value, that is a. So I just need to close the bracket. Next one is the solution in Power Query. So I need to bring in the n and the table into Power Query. So the first is n. I will go to data from table orange. I will remove the change style step here, and then I want to get these values by just typing it at the end here. It will extract the value from column 1, and the first value is 0. So it is this value, and then I close and load to only create connection. Okay. The next is this table, data from table orange. I will extract this column as list. Right click, drill down, and then I use list buffer. Next, I will add a new step, and I will use list accumulate. The list is cells. The initial value will be an empty list, and then I use this function. It will be a concatenate with another list. And this list will be, if A is an empty list, then I will extract the first value of this list. The sales list here, the first value will be open curly bracket 0. Otherwise, it will use the formula that we usually use. So here, before I continue, I will need to calculate alpha first. So what I do is, I will add another step here. So alpha is 2 divided by EMA n plus 1. And I call this step as alpha. And then I come back to here. It will be alpha multiply with the current value, that is v, plus 1 less alpha multiply with the previous value, that is list dot last of a. Now I just simply rename this query to maybe EMA of n, and then go to file, close and load to, and then I place it here. I will format it with comma 0 style. Now let's come to the DAX solution. Excel solutions are quite straightforward. However, when it comes to DAX, we need to find a workaround, as DAX doesn't allow referring to the previous results of itself. Different from the first two demos that use an accumulation approach, EMA is more complicated. This time, we will try a closed form approach. So what is it? It is a formula that you can calculate directly the current value without step-by-step repetition or recursions. Here are some examples. Compound interest and Fibonacci, as you can see on the screen. How is it different? Recursive formula is something like, to get today's value, you need yesterday's value, and yesterday needed the day before, and so on. The closed form is something like, here's one formula that jumps straight to the today's value in one step. So it's like choosing between climbing a staircase step by step, that is recursions, or taking the lift straight to the top floor, that is closed form. We need to find a closed form formula of EMA. First, start with a base case. Here you can choose any initialized value for x0. EMA0 can be 0, that is a pure closed form from 0. It can be x1, the first value, so that it can have a fast start, or it can be an average of the first n values, so you can have the smooth start. Next, this is the formula for EMA at time t. We expand it once, and then keep doing that until everything is expanded. I will replace 1 minus alpha with beta in the formula to simplify it. Finally, this is the closed form formula for EMA. We use it in DAX. Before moving into Power BI, I will create a formula in Excel so it's easier for you to understand. I will need to use the closed form function that we have just discussed. So here it equals alpha multiply with the sum, and it will be like this. Sum of this anchoring the first row, multiply with open bracket 1 less alpha to the power of t less the cumulative of t up until current t. So it will anchoring the first row, and then close the bracket for sum. The second part is taking EMA0 multiply with 1 less alpha to the power of t, and that's it. Okay, I will just copy down. Now let's move on to Power BI, how we can replicate this calculation in DAX. We have this one. I will change the value to 7. Okay, now we will add a new measure for EMA. So it will be 3.2 EMA. Similar to the first two demo, I will put if aside to only do the calculation when the sales amount is different from blank or 0. If it's true, I will declare some variable. First one is the end days. So I will refer to the value of this slicer, that is end days value. Next one is alpha. It will be equal to 2 divided by open bracket n plus 1. Next, I will call one less alpha as EMAB, so I can use it later in the formula. The next variable is I want to know the current period index. So I have already added that index column to the original table, so I can use that index column here. I call it current ID equal to selected value of the index column. And then I return the calculation here. It will be alpha multiplied with a calculate function, and this is the sum x of the table. The calculation is the sales amount multiplied with EMAB to the power of current ID less the current index in this table. And then I apply some filter context here. First one will be index less than or equal to the current ID, and then I remove the filter of the calendar table in this matrix. I close the bracket. The second component is EMA0, so I need to calculate by removing the calendar filters, and the index will be 1. EMA0 multiplied with EMAB to the power of current ID. So this is the measure. Now I just simply drag it to the matrix and the chart, so we can see how it looks like. Now I just apply the whole value formatting. That looks good. Another measure I want to create so we can see it side by side with sales and EMA is the SMA, simple moving average. So I will create another measure and call it 3.3 SMA. This measure will be a little bit simpler than the other one. I also declare the variable for end date and the current ID, selected value of the index. The calculation is calculate average x of EMA using the 3.1 measures. Index is between current ID less n and less than or equal current ID. And then I remove the filter of the calendar table. Now I just drag it into this table and the visual here, so it also hold number with comma separator, and I change the color a little bit. Go to line, SMA, maybe I change it to green. For EMA, I change it to blue so it matches the one we have in the Excel file. Alright, so that's it for this demo. Okay, this is the last demo and also my favorite problem for today's session. It is using simple moving average method to forecast future values. SMA is just an average of the last n value. Each value weighs the same. I mentioned it in demo 3 for EMA, but this time it is used in forecasting. This means it is based on actuals at the beginning and then on previous forecast in the later periods when there is no actual data. Let's take an example of 4-month SMA forecast. This is the formula for it. We have a timeline here. The first 4 months are actual data. The following is forecast period. I recount the forecast period so it's easier to explain. Forecast month 1 equals to the average of the recent 4 months actuals. Forecast month 2 equals to average of the recent 3 months actuals and forecast month 1, etc. Let's do the calculation in Excel as usual. This is what I have prepared for demo 4. It has some actual number here and the window is 4 months. Forecast period for 6 months. So first thing is I need to find the next day of the previous month. So it will be E day at 1 month. I press Ctrl Z so the table won't expand, and then I drag the formula down. For this one, there's 2 options. So you can simply use average of the 4 months here and drag the formula down. However, this formula is not dynamic. If I change this input to 3 months, it won't update accordingly. So what I do is I use average fs function. So I need to refer to all of the values before this date. We'll select it. But I don't want to use the table reference. I will select another the columns, and I change this one to column D, and I encode the first row, and then the condition here is on the day column, so it will be column C. Criteria here is higher or equal to each day of the current date minus the window scalable bracket. Alright, and then I copy down the formula. So it still return the same result, but it is dynamic now. So if I change it to 3, it is dynamic. Okay, I've changed back to 4. Now let's come to dynamic array solution. So first, as I also want to create a chart, I link the actual days to this cells and the last actual value in this cells, and then I start generating a list of days. So I also use eDay function. The starting day will be the previous day, and number of period will be, I will use sequence with number 6 here, so it will generate a list of 1 to 6, and then each day will create the day list. Next one is the value. This time I cannot use scan function because scan can only store one previous value, as we have discussed. So what I do is I use the combination of reduce and vstack to store multiple previous value. So first I use reduce function. Initial values is the previous 4 values, the last 4 values of the value column. So I will use take function and then select this column. Number of rows will be minus the last 4. The array will be the month counter. So I will use sequence again. It will be the counter from 1 to 6. Like this. Okay, now I come to the next row. The third argument is the function. So I use lambda a comma v similar to the scan function. We stack the arrays vertically. So here I stack the accumulator A and the new result calculating by the average of the last 4 values. So it will be take A, last 4 value of A, so it will be minus the window here, and then I just close the brackets. However, it returns more result than we expected because it also includes the first 4 value here. So I use the drop function to remove the first 4 value. At the end here, number of rows will be this window. Okay, so this is the result. This is a chart for it. For the Power Query solution, it is quite similar to this formula. So I will bring this table into Power Query. Go to Data, from Table Orange. I click Advanced Editors because I want to bring in the windows and the forecast period as well. So I will add some step at the top here. So first is the window. The window has the name range called move EVG underscore window, and I want to extract the first value of column 1, so it will have this syntax. Now I can just copy this for the number of forecast period, and I call it period like this, and it will have this name range. Click done. Now I need to change this date type to date, replace current, and I want to find out the last actual day. I select that columns, go to transform under date latest, so it will get the latest day. So I rename it as max day. This is the last actual day. Then I add a new step and I calculate the start date. So it will use the function day add months. Number of months will be minus window plus 1. So this is the start date of the first window. Then I come back to the change type. I just add a new step and equal to change type. And now I just filter all the day before any random day for now, and then I replace this hard-coded day with the start day that we have just created. Now I will sort this column ascending, and I will only take these 3 values, and I use list buffer again for this value. So these are actuals, so I will rename it to actuals. The next step is to calculate the forecast, so it will be list accumulate. For the list here, it will be a little bit different from previous case. So I want to use a list of number from 1 up to the forecast period, and the starting list will be an empty list. Accumulator will be a comma b inside the bracket equal higher than, and then the calculation here it will be a concatenated with another list, and this list will be list average, that is the new average value, and I use list last n to find the last values of actual concatenated it with a number of value I would like to take is equal to window. So this is the result. I will rename it to SMA forecast, and then go to file, close and load to, select table, is this single sheet, and I place it here. I need to move it down here. Something wrong with the formula. Let me double check the query. So this one should be higher or equal. So let's close and load again. Yep, so it returned the same result. Now I can format it with comma 0. Let's move on to the DAX solution. We need to find a workaround. I will use a closed form approach. First, we need to calculate a coefficient matrix. As the window is 4 months, we have this 4 times 4 matrix. It will be applied to actual months 1 to 4 on the rows to calculate each forecast month 1 to 4 on the columns. The coefficient for forecast month 1 will be the same, 0.25. For forecast month 2, actual month 1 will be dropped and forecast month 1 will be added, so their coefficient will be calculated as follows. All coefficients of forecast month 1 will multiply by 0.25 and add to coefficient of actual months 2 to 4 of 0.25. Therefore, we get 0.06 in actual month 1, while other actuals have 0.31. Similarly, we will calculate coefficients of forecast month 3 and 4. Next, to calculate coefficients for the next window, that is months 5 to 8, we can use matrix multiplication by creating a copy of the initial matrix and multiply them together. Similarly, for forecast month 9 to 12, we use the second matrix window multiplied by the initial matrix. Let's formulate this so we can apply it to a different example. Let's call the weight 1 over n as A and 1 plus A is B. We have this initial matrix. Let's transform it. We take out A's time and get another matrix here. Now we can see some patterns. It can be calculated using this formula where M0 is the initial matrix, C is the column index, and R is the row index. The next window matrix can be calculated at the initial matrix to the power of the window counter. We can build these coefficient matrices for as many as the number of forecast periods we need and combine them together into a single table for lookup in DAX. To build this lookup table in Power BI, there are many options. You can do the calculation in Excel and import or copy it into Power BI, or you can build it in Power Query. Another option is to build it in a DAX table. As this solution is for DAX, I will also demonstrate the DAX table option. You may choose other options if they are easier for you. Let's see how I did that. Before we create the coefficients matrix in DAX table, we need to create two parameters, one for the window and one for the number of forecast period. So I will go to transform data and I create new parameters here. First one, I call it SMA underscore window. Number, and I will use number 4. I put it in this folder. And then the second one is number of forecast periods. I call it SMA underscore forecast periods. Similarly, it have to have number data type and I would like to forecast for 6 months. Okay. And I want to load this into the data model so I can use it in the DAX table. So I will right click it, enable load for both of them. Okay, close and apply. To save us some time, I have already added the DAX for this and I will explain it step by step for you. The first step is to declare the value of the window and the forecast and I call them as W and F. Then I calculate the weight, so it will be 1 over W. In our case, it will be 0.25. And then I will declare a factor that is 1 plus weight. And I created a table counter using generate series. So it will generate a table, have the list of number 1, 2, 3 up until W. Then I call T1 as my initial matrix. For each row counter, I will generate different value for the columns. So first I declare the current rows counters as n. I adding the columns to the counter table here. And this column is called add value. And I use the same formula that we have discussed in the slides. And then I rename the columns in this result table. So the rows become columns and then values is still values. I will show you how it looks like. So I just copy T1 here and paste it in the return and I commit. Then I go to the data view. So you see this is the initial matrix. It is just showing in the unpivoted side. After I have the initial matrix, I perform matrix multiplication. Unfortunately, in DAX, there is no built-in function for magic multiplication like in Excel we have a month, but in DAX we need to use different methods. So I use left join the two tables. So both of them are table 1 because they are just a copy of the table. And then for the second table, I adjusted the column index is the column values plus the window value. Then I group them and sum the products of the value 1 and value 2 to get magic 2. Let me show you the table 2. So it's simply having all the forecast period from 5 to 8. Then similarly, I do the same thing for table 3, 4, 5. So I just make a copy of table 2 and change the table name here to 2, 3, 4, 5. And I do it up until table 10. And then in the final table here, I just append them on top of each other. And then I only filter for the number of forecast period that I need. And I rename those columns to base numbers, forecast numbers, and value. Base numbers just mean the actual period number. And I return this table. This is the combination of all coefficients from periods from 1 to 6. And then I will use it in my measure. I have already created a placeholder here, so I will use it. First thing, I declare the value for the window. F is the forecast period. Then after that, I calculate the max day similar to what we did in the dynamic arrays solution. So max day is equal to calculate max of SMA date, and I remove the filter context of calendar table. This is the last actual date. Then I declare the start date of the first window. So it will be E date of the max day variable minus W plus 1. And then the current date will be just simply the current start of month. And then I find out what is the forecast month number. I will use the diff function between max day, that is the last actual day, and then the current date, number of months. And then the next thing is finding out what is the current item. So for your information, let me move to our table so we can see. Item here includes item A and B. So this is just to demonstrate that if the user want to drill down into A or B, they can see different results separately. It is hard to do in a Power Query because you need to calculate the SMA for A and B separately instead of combining them together. Now I come back to this. So I need to find out what is my current item. So it will be if the forecast number is higher than 0 and is less than or equal to the number of forecast period. I will do this calculation. So it would be selected value of the item columns and remove the context of calendar table. Next, I will calculate the actual. That is equal to calculate table, filter function SMA based on the items equal to the item variable, and the date will be higher or equal to start date. And the condition here is to remove the filter of the calendar table. Next, I need to find the base number, that is the month number of the actual. I will add column. So it will be the name of the column is base number. It will be the window less the ranking. So I will use the dense ranking in the accessible order by date in a descending order. So I need to reverse the order plus 1. And then the next variable is calculate the coefficient. Add columns to the base number. Column name is coefficient, and I do the lookup using lookup value function. I will look up the value based on base number. The forecast period is based on forecast number, close bracket. Let me reformat it so it is easier for us to read. Okay, output equal to sum x. So it will be the sum product of all coefficients and the corresponding actual number. So I will use coefficient table here. Value is the actual values multiplied with the corresponding coefficient, and I return the result. So the result here is if current day equal to the last actual day, then return the actual number. Otherwise, return the output. Alright, this is the measure. Let's commit it. Okay, so here's the result. Let's double check it again, the Excel results. So it is 450, 487, 409, 450, 487, 409. Yep, that's look good. The only thing is that although the number of forecast period is 6 months, why does it only show 3 months here? That's because the calendar table hasn't included the forecast period yet, so we need to go into the query and fix the calendar table. So here for the end date, I need to adjust this one. I put it inside a list and then I use day add months and it will be add to the last day in the SMA table. So it will be list max. It will generate the last actual day. Number of months is the SMA class period and it need to be in a list, so it will be like this. And now I just simply close and apply, and after it's finished it should show news period here, as you can see. Good job! We have gone through so many examples and techniques to deal with recursion. Here is just a quick comparison among various tools we have covered. In Excel, you can use normal grid formulas or spill array for recursions with these tools. Despite their flexibility and ease of creation, Excel has some limitation on the number of columns or rows, so it won't work with large data with more than, let's say, 2 million rows. However, it is good for prototyping when you want to quickly brainstorm a solution and check the result. In Power Query, there are some built-in functions we have mentioned. Power Query overcomes Excel limitation of around 1.5 million rows, but they will be very slow when the data is getting bigger, let's say 10 million rows. We need to write M codes, so it's a bit harder to learn than Excel formulas. Power Query is best for heavy extract transform and load transformation or ETL. Another limitation of Power Query is that it doesn't allow drill down into details based on report user selections. That is why sometimes we need to use DAX to deal with recursion problem. As there is no recursive functions in DAX, there are some creative workarounds we can utilize, such as accumulation and closed form formula. DAX is a good tool for reporting and large data. Thank you again for joining my sessions. I hope that you have been inspired by many ideas from this section to apply to your own problems. I would love to hear some feedback from you. Please use the QR code or URL. If you have any questions, put them in the Q&A box. You may also contact me by my LinkedIn or email on the screen. Enjoy the rest of the conference.